Hi everyone, we are going to carry on with another past paper questions. So, question 1.1, which one of the following physical quantities is a vector? We know already vector quantities and scalar quantities. Let's see our options. Distance is a scalar quantity, and then displacement is a vector, and mass is scalar, time also scalar. We know which one with direction, vector, displacement with direction. Answer is B. Next question. In the equation, V final equals V initial plus A times delta T. SI unit for A times delta T. What we know, A times delta T is velocity. So unit of velocity is meters per second. Next question. From acceleration time graph, they're asking you which one velocity time graph. Let's check our acceleration time graph. As you see, we have positive acceleration and negative acceleration. Positive acceleration means velocity increasing, and the negative acceleration, velocity decreasing. We can check our options. First one, decreasing, option A is wrong. And then option B, as you see, velocity decreasing first, so that one also wrong. And then option C, velocity increasing, yes, this is correct for first one, for positive. Next one, they said negative, second one negative, but still increasing. That one also wrong, because second one is wrong. But option D is correct. Why? Because first one, as you see, increasing and decreasing. Positive acceleration and negative acceleration. Next question. So let's see what they ask. Wave travels through a medium. Okay, which one can travel in medium? So let's check our options. Okay, car, scooter, ambulance. So all of them sound waves, people. Option A, B, C, all of them sound waves. But this one, light ray, just electromagnetic waves, X-ray is correct. Because just getting from here, people, travels through a medium. Next one, number of waves passing a point every second is defined as, okay, let's see our options, speed, amplitude, wavelength, and frequency. Number of waves in 1 second, what was it? Answer is frequency, because we know frequency is number of waves in 1 second. So wavelength, distance between crest to crest or throw to throw, and then amplitude is maximum displacement from rest position to highest point, and speed, you know, distance per time. Next question. Which one of the graphs below best describes the relationship between loudness and amplitude? Okay, loudness and amplitude, same thing, people. We are using loudness for sound waves, amplitude changed to loudness. So let's see our option. Answer is A, because loudness increase, louder getting more amplitude increasing. Question 1.6. Loudness and amplitude, pitch and frequency. Okay, if you see loudness, please remember amplitude. If you see frequency, pitch, in sound waves, pitch. That's it. Let's continue with next one. Oh, sorry. Next question. Okay. Anyway, which vector diagrams below will result largest resultant vector? So let's check our options. As you see, C and D opposite direction, two forces opposite direction, of course, getting less resultant force. And this is only one single force, but B has two forces together, but same direction. If they have same direction, we are adding them to get total resultant force. Next question. Okay, let's see what they ask. Which one is correct? For this system, which one is correct? Let's see. All right, object coming from A to B. Okay, kinetic energy is equal to mechanical energy at A. kinetic energy. Okay, first option. And then gravitational potential energy at A is equal to kinetic energy at B. But we are not sure about it because at position B, it start from 0 or, okay, diagram. All right, let's check all options. And C, sum of the kinetic energy and gravitational potential energy at A is equal to sum of kinetic energy and gravitational potential at B. Yes, we are sure about this one. Why? Because we know mechanical energy remains constant in a closed system. Mechanical energy is constant. We know kinetic energy and gravitational potential energy making mechanical energy. They said mechanical energy at point A is equal to mechanical energy at point B. Answer is C. We cannot make sure about other options, kinetic energy, potential energy, but mechanical energy we are sure. Let's continue. Now this question about our electrostatics. Rubber balloon, okay, obtains negative charge. Okay, your object getting negatively charged. If it is getting negatively charged, what's going on? Of course, collecting electrons, collecting negative charge. Let's see our options now. Negative charge transfer from rubber balloon. No, if transfer from rubber, so getting positively charged. Positive charge, just leave this option because positive charge never move. Option B and C not correct answer, only D left. So transfer from human hair to rubber. So answer is D. Next question in multiple choice question, last question now. Electric circuit question. They said which one is correct for current reading on A1, A2, and A3. What we know for parallel connection, this is our main conductor, and after this point, resistors sharing currents. So A2 plus A3 giving you A1, current on A1. We can use I1, I2 with symbol of current also. So reading on ammeter A1 equals A2 plus A3. Answer is B. Current on A1 equals to current on A2 and A3. Why? Because they are sharing current. When they come to this point, also combine and making same currents like on A1. That's it. Multiple choice questions done. Let's continue with question 2. This question about vector and scalar, calculating vector quantities and scalar quantities. Let's see what they ask. Okay, just he starts at his desk and walks 5 meters east. Okay, 5 meters east from A to B, moving 5 meters east, and then walks 7 meters west from B to C. Okay, between A and B is 5 meters, and B and C is 7 meters. From A to C, how many meters left you will see? All taking 20 seconds. Okay. Use the vector scale diagram and represent two displacement of the man from A to B and B to C. We are gonna draw. It's easy one. He is moving from A to B. First one, 5 meters, and then just showing like this from B to C, 7 meters. That's it. You're just drawing with arrow on the diagram. Next one. Change in position. They're asking you displacement from C relative to A. 2 meters left. Maybe we can show with this one. On this diagram, we can show 2.2. Answering 2.2 now. So what was our initial position? As you see, initial position is here at point A, X initial, and then just we can carry on with dots just to show that C, point C, same point, people. We are just showing like this, just like B, same point. So otherwise we cannot draw on same arrow. We are drawing from A to C. As you see, A to C, this is our displacement from initial to final position. To draw, to see direction of displacement, you are drawing from initial position to final position. 2 meters left or 2 meters west, you can say. Next question, calculate the total distance. Okay, we are calculating total distance. How? 5 plus 7 equals 12 meters. Why? Because from A to B, it was 5 meters. And then from B to C, total, it was 7 meters tall. So you are adding 5 plus 7, 12 meters. That's it. Is the one. So far, asking about distance and displacement. We know distance scalar quantity and displacement vector quantity. Next question, let's see what they ask. Explain why. Okay, calculate 2.2 different from 2.3. What was the 2.3? Let's remember 2.3 is distance. 2.2 is displacement, change in position, because we know change in position is displacement. So they're asking you people, what's the difference between distance and displacement? Let's see, total distance, everything you are adding, and then, but displacement, change in position, only difference between original position, first position to final position. Distance is just adding everything for distance. For displacement, only the x final minus x initial. Another differences, people, we can say distance scalar quantity, displacement vector quantity. Done. Question 2.5. Define the term velocity. Velocity is the rate of change of position. Rate of change of position, or velocity is rate of displacement also, because change of position is displacement. Rate of change of position. Calculate average velocity now. Okay, to calculate average velocity, we need displacement and time. Let's see now. Displacement, we calculate already. It was 2 meters. And then 2 over delta t. 2 over delta t, you are calculating like this. And 0.1 meters per second west, or to the left. Same direction of displacement. Displacement, it was left direction. So velocity also left. Okay, let's continue with next question. Question 3. All right, question 2 done. It was about vector and scalar quantities. Normally they ask calculate net force also in question 2, but for now only they focus distance and displacement. Okay, this question about motion. Let's see what they ask. A taxi driver traveling at speed 25 meters per second. All right. When a traffic light 40 meters ahead, change to red. Okay, so this driver has to stop. Okay, define the term acceleration. All right, first of all, what we know, this car is coming with 25 meters per second, constant velocity, constant speed. After that, he has to stop. So velocity will decrease. Velocity will decrease and final velocity will be 0. Okay, when they ask, let's see what they're going to ask. First of all, we know our speed is 25 and total distance 40 meters. Okay, define the term acceleration. What is acceleration? Acceleration is the rate of change of velocity. Rate of change of velocity. Next question. Is the velocity and the acceleration of braking taxi, okay, same direction or not? Not same direction. Why? Because you have negative acceleration. What was the negative acceleration, people? Please remember that multiple choice question from acceleration time graph to velocity time graph. Negative acceleration means velocity decreasing. If velocity decreasing, direction of acceleration different to direction of velocity. Now give a reason, okay, reason, velocity right, acceleration to the left, because we can say velocity decreasing. Velocity decreasing means acceleration and velocity, they have different direction. Another answer for 3.3, taxi is slowing down, acceleration is opposite direction to movement. Okay, calculate distance. the taxi traveling during reaction time. Reaction time means, people, still going with 25 meters per second. It means couldn't see, couldn't make sure. How many seconds reaction time? Okay, let's see. 40 minutes change to red. Calculate distance during reaction time. Reaction time, we need to know reaction time. It is 1 segment. We can go back and see reaction time. Okay, driver takes 1 second to react. Reaction time is 1 second. So moving 1 second with constant velocity and then slowing down in 2 seconds stops. Okay, we can draw when we answering those questions. Calculate distance the taxi travels during reaction time. Okay, we have different options here. Let's see all options. Let's explain. Acceleration is 0. Acceleration is 0. Because of that, you can use this formula directly. Vi times delta t is enough. Or other option is here, people, without acceleration. V initial plus V final. V initial and V final same because 25 going with constant velocity, with constant speed. And another option is here, delta x equals, oh, this one is the wrong one. They should write delta V. Delta V must be here. Let's change it. This answers from memorandum. Okay, delta V equals delta x over delta t. So you are getting delta x equals delta V times delta t. 25 times 1. You have different options, people. You can get same answer, 25 meters for all. What we know, moving with constant velocity, constant speed in 1 second. In 1 second, moving with constant velocity. Okay, first of all, going with constant velocity and then slowing down and stop. Let's see what else they're asking. Will taxi stop at the traffic lights? Show all calculation. Okay, now we are gonna calculate everything. Okay, so first of all, taxi driver, he's moving 25 meters. He's coming around here during reaction time. 25 meters gone already. And then extra how many meters is gonna move? Let's see. 25 meters, this is our initial velocity after reaction time. Okay, we are busy with next motion for slowing down for 2 seconds. Time is 2 seconds and V initial is 25. What is V final? V final equals 0 meters per second. It is meters per second also, let's write. So first motion, I hope it was clear, it was easy because for 1 second, initial velocity and final velocity 25, constant velocity, we calculate 25 times 1, done. But now we have initial velocity, final velocity, we have even acceleration, but we don't have to calculate the acceleration for now. They don't ask me. If they ask, we can calculate. Let's see, we're gonna calculate this displacement and we'll add to 25. Let's see our answer now. As you see, people, delta x equals, what formula we are using? Delta x equals V initial plus V final. V initial, V final plus V initial, same. V final, it was 0. V initial, it was 25. And over 2 times time. Time is 2 seconds now. And then total displacement 25 meters. We have already another 25. We are adding and getting 50 meters. Answer is, will not stop at the traffic light because moving 50 meters. It was 40 meters total. Answer is, will not stop. We have other calculations here. You can use other formulas, people. You can get acceleration first, and then you can use this formula long way. We don't need this one. First one was easy one, nice one. Okay. We have other options. You can use all equation of motion, which one is best for you. And next question, they're asking you people, draw a graph, position time graph. So how we are getting this graph, people? First of all, it is constant velocity, just straight line, just drawing like this for first second. And then for the next 1 second, you can calculate displacement and you are gonna see 43 points. You will add, of course, to 25. You must just calculate that one. And then you are calculating for 3 seconds. And finally, you are getting 50 meters. This is our graph. But for graph, please don't forget to write title, position, time graph, velocity time graph, whatever you have, and then just correct labeling everything. Make sure. Okay, let's continue with question 4 now. Question 4 about velocity time graph. From graph, they're asking you some questions. Now, first question, initial velocity. Just from graph, initial velocity is 5 meters per second because 4 and 6. As you see, we have 4 and 6. Between 4 and 6, 5 meters per second. And direction north, how we know that? Because direction of motion is north. It is given. Answer is 5 meters per second north. Next question, magnitude of the girl's velocity at 300 seconds. Okay, let's go to 300 seconds and go up and see 8, something, 8,2, I think. Yeah, 8,2, between 2, 4, but this one is not clear, but we can say 8,2 or 3, it's fine. Just getting from graph. So far questions just from graph. Next question, asking about what type of motion. We have uniform motion if your velocity is constant, acceleration is 0. We have uniformly accelerated motion if velocity increasing or decreasing. De-accelerate also you can say. Let's see what they ask now. From B to C. Okay, for this kind of questions, just check what's going on. Your velocity is constant, increasing or decreasing. From B to C, as you see velocity increasing. If velocity increasing, what kind of motion you have? Uniformly accelerated motion you have. You can say velocity is uniformly increasing or velocity increasing from 5 to 10 in 350 seconds. And then positive acceleration, speeding up, any of these correct. Okay, so describe the motion you can write, or uniformly accelerated motion also you can say. This is our answer for 4.3. 431. Okay. Next question, from C to D. Yes, from C to D, we have constant velocity. If you have constant velocity, you have uniform constant velocity, no acceleration, same speed, uniform motion also you can say. I hope it is getting easier, people. Just remember our first video, second video, third video. So similar questions they're asking. For final exam, similar questions coming. Let's continue. Distance covered by the girl from A to C. Okay, for this kind of questions, people, we are using area under velocity line. We are using area to calculate. Let's see our solution first. For this kind of questions, we are using area to calculate our distance from A to C. Now they ask, but sometimes they're asking all motion from 0 to 600 seconds. They can ask any, but now from A to C only. Okay, from A to C, as you see, it looks difficult, but it is easy. You will see now. We are using area. First area from A to B, it is easy one because we have rectangular here. So you can say it is our delta x1. And you can just separate from here, people. You can make another rectangular delta x2. And we have triangle here, delta x3. So first one, we have 200 this side, and other side, as you see, 5, 205, number one, delta x1. And then you have from 200 to 350, 250 this side, and height is 5. So to 150, 250 minus 200, 350 minus 200 is 150. 150 times 5. 150 times 5. And you have triangle here. You have 150 this side. And this height, let's say, from 5 to 10, right? Yes, it is 5. So 150 times 5 over 2. This is our delta x3. And you are just adding them all and you are getting distance from A to C. If they ask distance from C to D, you are calculating this area. If they ask you from C to E, you must calculate this area and this triangle. So we are using area to calculate our distance because they said without using equation. So we are using our graph to calculate our distance. That's it. I hope it is fine. Let's continue with next question. Now, acceleration. Okay. Now they're asking you acceleration, people, from D to E. They can ask from A to B, B to C, C to D, D to E. We have different acceleration, people. Only A, B, and C, D, they are equal because all of them zero. Velocity is constant, acceleration zero. If they ask from A to B, acceleration zero. C to D, acceleration zero. B to C, increasing. D to E, velocity increasing and decreasing, but acceleration positive and negative. So we should get negative acceleration. Let's see. V final minus V initial, delta V over delta T. What is V final for E? 0 velocity. And initial is 10. So 0 minus 10 over 50. 50 coming from where? From here, it is 550 to 600. Differences is giving you 50. Answer is negative 0,2 meters per second. Negative means, people, velocity decreasing. If they ask from B to C, also same process, but you will get positive because 350 minus 200 is 150. 150 over 5, because 10 minus, okay, sorry, 10 minus 5, 5 over 150. Yeah, 5 over 150, you are getting positive acceleration. Okay, now, which change in speed? Change in speed greatest, it means acceleration. They're asking you, change in velocity is much better. Change in velocity is greatest. So, from D to E. From D to E. Why? Because you can see, people, first one, let's show here. First one, people, in 150 seconds, changing only 5. But this one in how many seconds? In 50 seconds, changing from 10 to 0. Because of that, explain change in speed from D to E, 10 meters per second, and then in 50 seconds, shorter period, shorter time. Okay, you can say, or you can just calculate acceleration for this one, all of them, and you can say another option. Okay, question 4 done. Let's continue with question 5. Energy, work and energy questions. Convert 14 meters per second to kilometer per hour. From meter per second to kilometer per hour, short way times by 3.6. Short way, just you can use this one, times 3.6, or with long way, people, 3,600 over 1,000. You can use this way. So from meter per second to kilometer per hour times by 3.6, but opposite one from kilometer per hour to meters per second, divide by 3.6. Next question, define the term kinetic energy. We know kinetic energy is energy of motion. And the potential energy, what was it? Energy of position. Next question, calculate the gravitational potential energy for 5 meters. Of 5 meters from ground. Okay, for this position, gravitational potential energy. We know gravitational potential energy is m times g times h. So we can calculate m is 0,01. 0,01. It is given here, mass of object, and g is constant number, gravitational acceleration, times by height. You are getting answer 0,49 joules. Done. Next question. Calculate the velocity of cell phone at height 5 meters. Okay, for this kind of questions, we are using our conservation of mechanical energy. EM1 equals EM2. So EM is potential plus kinetic. And then for first position and second position, okay, let's draw and show. Let's try to explain. So this question starting with EM top or EM1 we can say, starting with EM1 equals EM2. What is EM for what? For first position. So V initial for first position, V1, we can say V1 equals 0 meters per second. And for this position, we are looking for velocity now, V2. We are calculating V2. We know height for first position, it is 10 meters. And then for second position, 5 meters. Okay, so EM equals EP plus EK. EM equals EP plus EK. EM2, EP plus EK2. So EK1 is 0. Why 0? Because velocity is 0. We have only MGH for first position, but second position, we have both of them, potential and kinetic. Why? Because you have height and you have velocity. So you are writing all givens. If you want, you can just cancel mass. To make it easy, you can just cancel mass from now. So you don't have to use mass. So 9,8 times 10 is 98. This one coming other side, negative. You can calculate from now, but we are using mechanical energy, conservation of mechanical energy. Question 5.4 done. Next question. Cell phones mechanical energy just before it's ground grid. Okay. Asking about mechanical energy. People, what we know, mechanical energy is constant. Mechanical energy is conserved in a closed system. Mechanical energy remains constant in a closed system. Answer is equal to. Okay, question 6. Waves question. This question about waves. So first of all, they're asking you amplitude. We know amplitude from rest to highest point. This is 40, but what you need? Centimeters. Okay, 40 centimeters, but they said in meters. So you must just convert it. 40 centimeters equals 0,4 meters. Amplitude, if they ask you amplitude from rest to highest point. Okay, next question. Just label the points. This point D is draw because lowest point, and then E is crest, highest point. Next question. 2 points in phase. In phase means when they have same direction, particles, same direction, if going down or going up, or same position, exactly same position other way. So it is our first wave, and this is our second wave. Let's see, you can write A and C. As you see, A is just going down in first wave. Second one, as you see, exactly same position, but on second wave. Another position, and I think we don't have out of phase also another thing, people, if they have opposite direction. So how many waves in the diagram? That's our question. So let's see. It is positive pulse and negative pulse, one wave. And another one, positive pulse, negative pulse, another one, and half. So answer is 2.5. Next question, calculate the wavelengths. How can we calculate wavelength? We should check other givens. Speed is given 0,4. Okay, frequency is given. We can calculate with our formula. So V equals F times wavelength. V is given, frequency is given. You can get wavelength 0,8 meters. Next question, distance D. Okay, we are going to calculate distance D now. Wavelength, what was the wavelength, people? For one wave, distance for one wave. We are looking for D now. We are going to calculate D. How many waves we have? 2.5. So 2.5 times, okay, this one is here, 2.5 times 0,8. 0,8 because our wavelength is 0,8. We calculated here. Wavelength is 0,8. 2 times 2.5 times 0,8, 2 meters. Distance is 2 meters. I think it's okay. Other option for this question, people, V equals distance over time for all Distance now, just all of them. Time is 5 seconds for all total waves, all of them. 5, so you are getting with other option with equation of motion. You can get for distance, for speed. All right, so I think it's easy one because wavelength is 0.8. We have 2.5 waves, 2.5 times 0.8. Next question, question 7, electromagnetic waves now. So let's see what is given. This table is given. Okay, so what wavelength of notes? Okay, frequency given. Anything else? Any numbers here? Nothing. Okay, let's see what they ask. We know already, right? What is wavelength? What is frequency? Frequency, number of waves in 1 second. So write down the independent variables. Independent variables, of course, notes. So which one player can control. Okay, and then others, dependent, rest of them dependent. You can say frequency or wavelength. Next question, draw a graph between frequency and wavelength. Frequency and wavelength, you can use just this table. If you wavelength 3, frequency is 10, because wavelength and frequency, people, just opposite each other. If one increase, other one decrease. If one decrease, other one increase. They have opposite. Let's see our graph. You can draw, you can use these numbers and draw a graph like this. And then we can, as you see, people, one is increase, other one decrease. You can see wavelength and frequency. Next one, they said y from graph. What can we say? Frequency and wavelength inversely proportional to each other. If one increase, other one decrease. I hope this one is graph. You can just, for this kind of questions, for all questions, people, please try first. All right. So you have past papers already. Please try first. If you don't understand any question, and come and see video, and then just like that you can do. Or even with this video, you can just pause when you see question, just pause video and then try first, and then you can check answers. All right. Because of time, I have to carry on. So next question. X. Okay, calculate the speed of sound for X. We know wavelength, we know frequency. What was the speed? Speed equals f times wavelength. Frequency times wavelength. We can just calculate with our formula. V equals frequency times wavelength. Next question, question 8. Question 8. Okay. Oh, we said question 7 about electromagnetic waves, but this is sound waves, sorry. Question 7, sound waves. Question 8, electromagnetic waves. But basically same calculations, people, only speed change to speed of light. Okay, now in another table here, we have another table. And in this table, what is given? Type of radiation given and frequency given for each. Okay, let's see what they ask. First of all, oh, sorry. Okay, choose the frequency from B and just match this one. How we know, people? We must just choose, we must just remember our electromagnetic waves. Electromagnetic waves starting with radio waves with lowest frequency, longest wavelength. And then when you go to gamma, gamma is the last one. Gamma has shortest wavelength but highest frequency. So which one? Just this 811 between these two. So 811, let's start with 813. 813 has lowest frequency. Which one lowest frequency? 813 is B, because lowest frequency. And then gamma is highest frequency, is A, 10 to the power of 23. And then between these two, 811C, 10 to the power of 16. I hope it is clear. Just remember, radio waves, they have lowest frequency and longest wavelength. Maybe we can show with drawing. It's going to be much better, much easier for you. Frequency is number of waves in 1 second. For radio waves, if you are talking about radio waves, people, wavelength around kilometers, maybe just 5,000 meters, 5 kilometers wavelength, but let's say 5,000 plus minus, of course. So 5,000 meters, 5 kilometers, but number of waves means frequency, less frequency. Okay, just remember radio waves with lowest frequency and longest wavelength, and gamma rays, highest frequency, shortest wavelength. Done. Let's continue with next one. Write down each following types of radiation. Types of radiation, let's say you can, okay, write down use of each. This kind of question you should remember, you should read in your textbook, people. Okay, for which electromagnetic waves using for what? You can just see examples here. Using for what? Infrared radiation, and the other one microwaves using for what? Microwaves oven, which one we are using once, and even cell phone connections using. You can see all examples here. Okay, let's continue. Name the type of radiation. You know already, it is X-ray. Next question. Why we are using X-ray to see our bones? Because high frequency, because of high frequency can go on soft tissues and soft tissues of humans, but not bones. Because of that, we can see, because reflecting from bones, and then just you can see, you can get a picture with X-ray. But it is dangerous, you know that, right? Using machines, and then you must stay away. If you have to, you must just go and get X-ray, otherwise you must stay away. Okay, danger of type of radiation, you can see damage living tissue and then just cause cancer. So it is dangerous, people. If you don't have to, please stay away. Okay, now we are calculating energy. Wavelength is given. If wavelength is given, we can calculate energy by using hc over wavelength. H is Planck's constant number, c is speed of light, and you can get energy. Next question about magnetism. Define the term non-contact force. Non-contact force, what was it, people? Non-contact force, object without touching. Force on object without touching the object. Force on object that's with distance. Examples: gravity, weight, gravitational force. Weight and gravitational force, same thing. And then magnetic force, you know already. Electrostatic force, another example. Now, between these two, what kind of force between these two people? As you see, just moving from one to another. So attractive force. We have attractive force between pole 1 and 2. And then they said, what's polarity? Pole 2. Polarity, it's gonna be north, because we know direction of magnetic field from N to S. Remember, natural science, N to S. Direction of magnetic field lines from N to S. Because of that, pole 2 is N, pole 1 is S. Question 10, electrostatics. Okay, so electrostatic questions now, charge given. We have two objects, A and B, with different charge, positive and negative. First of all, people, they are asking you which sphere has excess electrons. Answer is B, because it is negative. And then next question, when they touch each other, which direction of electron transfer? Direction of the electron transfer from negative to positive, B to A. If you have two positive numbers, electrons transfer from small number to big number, people. Always from small to big, all right? Because small number means more electrons. If you have negative, positive, from negative to positive. If you have two negatives, also check which one is smaller. Okay, start from smaller one. Next question, calculate the new charge. How can we calculate new charge, people? We can use Q1 plus Q2 over 2. You are adding two charges and divide by 2, getting average, or average, we can say total charge, final charge, not total. Total charge, if they ask you total charge, Q1 plus Q2 only. But if they ask you new charge for each, just add and divide by 2. Other name is final charge. Number of electron transfer. To get number of electron transfer, people, we are using formula N equals Q over E. So this is delta Q, people. Just remember that this Q in formula box, it's given like this. But if you see Q, remember it is delta Q, change in charge. So how we are getting change in charge, people? Firstly, option 1, you are using B, object B, final charge, we calculate minus initial charge, divide by electrons. But if you have positive, so you can use positive this one also, just remember that. So positive, Q final minus Q initial over charge of electrons. It is our first option using B. Second option, let's see, using A, getting negative, so you can use negative for charge of electron. Okay, finally you should get positive number. All right, for number of electrons we are getting positive. Next question, electric circuit question, last question for today from this past paper. It is our last question. So electric circuits, let's see what we have. We have 12 volts on the battery, 2A for main conductor. So we can calculate V2. It is easy now because this current main conductor, they are sharing first and then coming to here. So we have 2 times 8. V2 is 8. We can get it. And then for parallel combination, you can get, as you see, we never start question. First of all, we are just working on circuit. What can we get? What can we do? Okay, let's just show on this circuit. First of all, people, this is your current. This current sharing first. After that, combine from this point. It is 2A. So 2 times 4 from Ohm's law, V equals I times R. So 8 volts, V2, 8 volts. And then V1, 12 volts. So for parallel combination, how many volts left? If we have voltmeter here, only 4 volts left. Okay, let's see what they are going to ask. For now, we know these things. We know V2 now, 8 volts. And then we know for parallel combination, we have 4 volts. And then we can get current also. We calculate everything. Okay, let's see what they're going to ask. Okay, 4 volts over 3 is giving you current for A3 and then current reading on A3. And 4 volts over 6 ohms giving you current reading on A2. Okay, we know these things. Now it's easy to answer question. Let's carry on. Let's see what they ask. First of all, they are asking you total resistance. How we are calculating total resistance, people? First of all, we are calculating parallel combination, and then we are adding 4 volts. As you see, parallel combination giving you 2 ohms, 4 plus 2, 6 ohms for total resistance. Other option is here. If you have 2 parallel combination, it is option 2. And then calculate reading on V2. We calculate already, people. Do you remember it? We said it is 8 volts. How we are getting 8 volts? V2 equals, R equals V over I. So R is 4, I is 2. How we know? We explained already because main conductor is here. Coming from Ohm's law, V2 is 8 volts. And then calculate reading on A2. Okay, now we should think about that, people. Or we calculate, we said we did show already. You have 8 volts here. We calculate from Ohm's law. V equals I times R. So I is 2, R is 4. Answer is 8 volts for V2. For parallel combination, how many volts left? We said, people, do you remember that? 4 volts. How we know 4 volts left? Because 12 minus 8 total voltage. And then you can get current on A2. Current equals voltage for parallel combination over R for which one with A2. So 4 over 6. 4 over 6, 2 over 3, 0, 67. Yeah, just maybe calculation only, but it's fine. You will see now. But 4 over 6. Okay, let's continue. Let's see our solution now. So I equals V over R, 12 minus 8. I think you are okay about this one. Why we are writing 12 minus 8? 12 minus 8 over 6, 0.678. Let's see anything else. Are they asking? Amount of charge that flow on M meter for, okay, for A1. For this question, people, what we know, charge equals current times time, QIT. Just to remember, you can say QIT. Q equals charge equals current times time. You are getting, because we know already current, time is given in question, and then we calculate. Next question, reading on A1. Okay, I will reading on A1, be effective 6 ohm resistance remove. Okay, if you remove 6 ohms resistor, if you remove something from parallel combination, your current, what's can happen, people? Answer is decrease. Your current decrease. Why? Because your total resistance increase, people. Because your total resistance increase. For now, what is our total resistance? What do you calculate, people? You got 2 for parallel combination, 2 plus 4, 6 ohms. You have 6 ohms for now for total resistance. Our total equals 6 ohms. And then if you remove 6 ohms from here, your total resistance 3 plus 4, 7. New total resistance is 7 ohms. As you see, increase. Total resistance increase. If your total resistance increase, current will decrease. You just remember this one between current and resistance. If current increase, resistance decrease. Like this, let's draw. When they play, resistance, and then other side, current. If one increase, other one decrease, people. Just remember. Okay, I think we have done. Let's see any other questions. 1.3, okay. We have another question, explained answer. Oh, we explained already. Because total resistance increase. Okay, we have done for now. See you next lesson with another final exam question.